Hello friends, welcome to Block Bytes. The modular blockchain space is getting exciting day by day. More and more new projects are launching into this ecosystem, trying to make a mark in an otherwise already populated space. But why is this such a hot topic in blockchain? In this video, I will like to present my understanding of the space. I will keep it as simple as possible, as it can quickly get technical, and I am not technical. Let's start by understanding the meaning of modular and how it differs from monolithic blockchains. A blockchain includes execution. This simply means a way to process transaction. Settlement. This means that all transactions are added to the chain forever after processing. Consensus. This means that all the nodes in the blockchain agree on how a block of transaction is to be created. And data availability. This means that the data corresponding to each transaction is available to all the nodes and by extension to the public. A monolithic blockchain does all of these four tasks. In a modular blockchain, these four tasks are separated and done by different blockchains. But why would a blockchain want to do that? As monolithic blockchains grow in terms of users, it starts to strain its network. Think about it this way. Why do we have assembly stations in factories? By dividing the work into different parts, you can increase the factory production and meet the increase in demand. The same fundamental principle applies to the concept of modular blockchains. Let's take an example to see how this manifests for a blockchain. Ethereum is the most widely used public blockchain today. It is a monolithic blockchain that has by design preferred decentralization over scalability. This means that as more and more people start to use the chain, it becomes expensive for them since it cannot scale up to the number of transactions to meet the demand. On the other hand, blockchains like Solana have preferred scalability, offering faster transaction speeds at lower costs. To address this problem on Ethereum, new blockchains called Layer 2s appeared. Layer 2s took the execution load away from Ethereum, so collectively these Layer 2s and Ethereum became a modular system. These Layer 2s have focused on scalability from the blockchain trilemma and depend on the base chain Ethereum for security. With Layer 2s taking over execution from Ethereum, we also see projects that take the task of data availability away from Ethereum. Projects like Celestia, Polygonal Veil, and EigenDA are designed specifically to remove the burden of data availability. Ethereum is also improving its data availability with data availability sampling, which promises to be another big update to the chain after the merge. Just a quick side note here. Data availability does not mean that transaction data is available forever. It is usually available only for 1 to 3 months, after which it is purged. But what if this data is needed in the future? Ethereum allows for something called archival nodes on its network. These nodes store Ethereum's history on them and are used for data retrieval as and when needed. Now, let's look at the advantages of the modularity brings to blockchains. First, scalability. Outsourcing transaction processing and data storage allows for more transactions to be processed concurrently. Flexibility. Modular blockchains are more flexible regarding trade-offs and design because they offer more choices for developers. Ability to launch new chains. Modular blockchains enable the development of new chains adapted to specific use cases or applications. And finally, security. Modular blockchains lower the possibility of a single point of failure and make it more difficult for hostile actors to disrupt the system. Besides Ethereum, we see modularity come in different forms across the blockchain ecosystem. According to a blog by Visa, they group together different blockchains based on their degree of modularity. The first type of blockchain is monolithic, which comprises Bitcoin, Solana, and Tron. These blockchains handle all four essential blockchain functions without the assistance of third-party chains. The polylithic category contains Cosmos, Avalanche, and Polkadot. These blockchains use multi-chain architecture, which include a base layer and numerous heterogeneous or homogeneous blockchains. They divide a single network into many pieces, each with a subnet dependent on the main network. The third category comprises Ethereum, Near, Mina, and Tezos. For specific activities, these blockchains combine their fundamental capabilities with external platforms. In lay terms, they manage some operations internally while delegating others to specialized networks, like layer 2 networks. On the other hand, semi-modular blockchains can still execute transactions independently, which means they can process and validate transactions within their own network. Finally, the fourth category comprises chains such as Celestia and execution-specific layer 2s like zk-Sync, Polygon, Hermes, Optimism, and Arbitrum. These blockchains are designed to accomplish specific jobs and cannot manage all blockchain functions independently. But that is not all. In the last few years, even layer 2s have started to modularize, meaning some of their own functions are beginning to move to other chains. Layer 2s use sequencers in order to compress and order the transactions into a rollup before sending them to Ethereum. The use of sequencers has allowed layer 2s to keep the cost of transactions down compared to that of Ethereum. But it has introduced problems. First, at the moment, most sequencer implementations of layer 2s include just a centralized server running in a data center somewhere. This is a big single point of failure for the entire layer 2. And second, centralized sequencers can delay adding user transactions if they wanted to. It needs to be trusted by the users of layer 2 that it will behave impartially, which is unsuitable for a trustless blockchain system. As Ethereum starts to see more and more activity settling on it because of these layer 2s, the centralization threat of these sequencers increases. The good news is that these layer 2 projects realize the gravity of the problem and have included decentralization of sequencers in their roadmap. Still, only a little has actually happened in this regard. Espresso Systems is one such project. Their shared sequencer system is a proof of stake blockchain running their consensus protocol Hotshot. It is designed to handle sequencing and data availability for rollups. It is blockchain agnostic, meaning Ethereum and non-Ethereum compatible blockchains can use it. To improve the number of its own validators, Espresso will open up to Ethereum validators so that they can participate in the block building process for the layer 2s and in return get paid. Espresso is currently under testing and has announced partnership with Polygon, ZK EVM, Off-Chain Labs, and other layer 2s. Astria and Radius are two other decentralized sequencer projects. Besides sequencers, some rollups like ZK rollups also use provers. Provers act as a layer of verification for the work done by sequencers. Their primary responsibility is to ensure that a sequencer is working as intended. Provers do this by creating and uploading proofs of the sequencer's correctness to the blockchain and are rewarded by doing so. Every ZK rollup currently has its own implementation of provers. The idea here is to outsource proving to a decentralized set of provers, similar to what we saw with decentralized and shared sequencers. Although layer 2s are working on decentralizing their own provers, other projects have started in this space. Risk Zero is one such project. Risk Zero has created Bonsai, a decentralized network comprising of proving nodes. Layer 2s can now easily outsource their proving to this Bonsai network. Other projects in this area includes Nil and Blockless. All right, let's recap what we have seen so far. Transaction execution has been taken away from Ethereum by layer 2 blockchains like zkSync, Arbitrum, Optimism, and Starknet. Although Ethereum still and will always continue to process transactions, it is much cheaper and easier to do via layer 2s now. Data availability is also outsourced to projects like Celestia, Polygon Avail, and EigenDA. Ethereum will continue to be used for data availability, especially for the layer 2s on top of it. Layer 2s are getting modular also by moving to a shared and decentralized sequencer and proven network. Projects in this area include Espresso and Risk Zero. The monolithic and current design of Ethereum, along with its preference for a roll-up centric future, has resulted in many projects in this space. But with all this activity, the amount of complexity is also increasing. We will soon see a phase of consolidation. We will see the space narrowed down to a few top players that will become general purpose and decentralized for most applications. I hope you like this video. Do like and share, and I will see you next time with another fresh bite. Bye.